This video is about learning outcome number 3, which is all about applying the range rule of thumb to estimate and interpret measures of variation. The range rule of thumb is a crude but simple tool for understanding and interpreting standard deviation. Here it is. The range rule of thumb says that the vast majority of sample values lie within 2 standard deviations of the mean. So we can use this to identify significantly high data values and significantly low data values. So we're going to designate significantly low values as any value that is given by the mean minus 2 standard deviations or less than that, or a lower value than that. And we're going to say that significantly high values are values that are given by the mean plus 2 times the standard deviation, or that are higher than that number. And typical values, those are pretty much what we would expect, are within 2 standard deviations of the mean. So they're between the mean minus 2 standard deviations and the mean plus 2 standard deviations. Or if we're talking about populations rather than samples, we would use this mu minus 2 sigma to designate the population mean minus 2 times the population standard deviation. I think this is easiest to see if you look at it graphically. We're going to say that any value that is within 2 standard deviations of the mean is sort of typical or not particularly significant. It's sort of what we would expect. We would expect values to be within 2 standard deviations of the mean. And so if we're looking at our population mean here, any value that is within that population minus 2 standard deviations and within that population mean plus 2 standard deviations, we're going to say that that's typical, normal, ordinary, not particularly significant. But any value that is higher than the mean plus 2 standard deviations, we're going to say that that's significantly high. And any value that is lower than the mean minus 2 standard deviations, we're going to call that significantly low. So let's apply this in an example problem. It says using the 40 chocolate chip cookie counts for the Chips Ahoy cookies. We have chocolate chip cookie counts for Chips Ahoy cookies. The mean is 24 chips. So the mean of chips in those 40 cookies is 24. And the standard deviation is 2.6 chips. We're asked to use the range rule of thumb to identify the limits separating values that are significantly high and significantly low from those that are typical or less significant. And then the question says, would a cookie with 30 chocolate chips have a significantly high number of chips? This is pretty easy to calculate. We just need to look at the mean plus 2 standard deviations and the mean minus 2 standard deviations. So to get the significantly low values, we calculate the mean minus 2 standard deviations. So the mean was 24 chips, and we're subtracting 2 times that 2.6 chips, our standard deviation. So that is 18.8 chips. So significantly low values, or chocolate chip cookies that have a significantly low number of chips, have 18.8 chips or less. Obviously, you can't have 0.8 of a chip. I don't know how we would measure like 100% of a chip, but you get the idea. If a cookie has 18.8 chips or fewer, then we will say that that is a significantly low number of chips. If you like chips, you might be disappointed if you get one of those cookies. Okay, so significantly high values come from taking the mean and adding 2 times the standard deviation. And if we do that calculation, we get 29.2 chips or more. So if your cookie has more than 29.2 chips, that's a significantly high number of chips. That's kind of a significant cookie. That's a significant number of chips. So the question says now, would a cookie with 30 chips have a significantly high number of chips? I think we can say yeah, it would. Because most cookies have between 18.8 and 29.2 chips. That's what the range rule of thumb tells us. So if we're talking about 30 chips, that's significant. It's more than that 29.2. It's in that upper range, what we would call a tail. It's in that upper tail or that right tail of the distribution. So that cookie with 30 chocolate chips has a significantly high number of chips. Now, the range rule of thumb also allows us to estimate the sample standard deviation. This is a very rough estimate, but if you know the range of the sample data, which remember, that's just the maximum value in your list minus the minimum value in your list, you can take that and divide by 4, and that's going to give you an estimate of that sample standard deviation. I really hate that this is an equals sign. It probably should be a not or approximately equals. I'm going to change that to approximately equals before I upload these notes online. So let's apply this in an example problem. This says use the range rule of thumb to estimate the sample standard deviation of the Verizon data speeds. And I believe this is megabits per second. We've got 38.5, 55.6, 22.4, 14.1, and 23.1. We're asked to compare the result to the actual standard deviation, which we calculated in an earlier video. It was 16.45 megabits per second. So here's the solution. Well, first we're asked to estimate that sample standard deviation. So we need to find the range and we need to divide it by 4. Well, the range just comes from taking that maximum value of 55.6 and subtracting that a minimum value of 14.1. So we've got that right here. I don't know why it says type an equation here. There's no equation to be typed. I will fix that as well. So that is our estimate of the sample standard deviation, 10.38. That's very different from that 16.45 megabits per second. Let's see how different it is by computing the percent error. Now remember, whenever you're computing the percent error, you're taking the actual value of something and you're subtracting that approximate value of that same quantity. So we're going to take the actual value of the sample standard deviation, which is the 16.45 megabits per second, and we're going to subtract that approximate value that was given by the range rule of thumb. And then we'll divide by the actual sample standard deviation, which we found in another video, the 16.45. If you do that, you see that there is a 38% difference, 38.9% difference between the approximate value of the standard deviation and the actual value of the standard deviation. So in this case, there's just a huge difference, and this approximate value of the sample standard deviation that we get from the range rule of thumb isn't a very good approximation. So that's how we do that. You just take the range and divide by 4. That will give you a very rough estimate of the sample standard deviation. And then this is how you get your significantly high and significantly low values. You take the sample mean and you subtract 2 times the sample standard deviation to get that lower limit. Anything lower than that, so less than that, is going to be, or if you're talking about counts, fewer than that, is going to be significantly low. Any value within 2 standard deviations, that's the mean plus or minus 2 standard deviations, you can think of those as typical, ordinary, exactly what we would expect. And then anything higher than the mean plus 2 standard deviations, we're going to call that significantly high.